Hi everybody. This is going to be our first Unit 7 video, and we're going to kick it off with exponential functions. Now, you saw these back in Algebra 1, okay, a little bit. Exponential functions are kind of unique because the variable, okay, x, is actually in the exponent position. So the b that you see here is what we call the base, and then the x is our exponents. So we have different kinds of exponential functions we're going to be looking at. We're going to look at exponential growth. So, as we go from left to right, you can see that our function is increasing very quickly. So as the x values grow, as the x values get bigger, the y values grow very, very quickly. Okay, and then it's exponential decay when we start off with really large y values, but as x increases, as we go to the right, our y values start decreasing. Okay, and we can tell what kind of exponential function we're going to have based on the base number. So we're going to have exponential growth if that base is greater than 1, and we're going to have exponential decay if that base is between 0 and 1. Okay, it can't equal 1 because if I have 1 to any power, it's just 1, so it's never going to grow. If it's 0, again, 0 at any power, we're not going to see any growth or decay. So that's why it's not equal to 0 or 1 here. Now, anytime we have an exponential function, we're going to have something new that we haven't talked about for any other kind of function so far this year. Something asymptote. Okay, an asymptote, I want you to kind of think about it as like a boundary line. Okay, for exponential functions, the parent function is going to have a horizontal asymptote at y equals 0, okay, which is just going to be the x-axis here. And even though it looks like our graph as we're going to the left is touching the x-axis, maybe it looks like it might even, it actually won't. It will get infinitely close to the x-axis there, but it will never actually touch the x-axis or cross over. If you looked at a table of values, you would see that the y values keep getting super, super, super tiny, but it never actually hits 0 or crosses over. So kind of think of it as a line that our function is just kind of hugging along as it moves toward negative infinity, or as our graph goes to the left here. Now, with any kind of function, we always look at the transformations. And really, they're pretty similar to all the other kind of functions we've looked at so far this year. Because our variable is up in the exponent position, anytime we're adding or subtracting a number from x, up in the exponent, those are going to be our horizontal translations. So if I have x plus some number, it's going to go left. If it's x minus some number, it's going to move to the right that many units. Okay, the k value out here, as normal, is down, okay, positives up, minus is down. And then the a value, so this is where it's kind of interesting, right? We have this base value b that is separate from the a value, okay? The a value is what determines if we have a vertical stretch or compression, so you can see the requirements down here. And then as always, if that value is negative, it's going to make our graph reflect over the x-axis. So let's look at some examples. Okay, this is going to be a pretty short video. I want to look at these functions, identify the parent function, the transformations, and then identify the location of the horizontal asymptote. Okay, so when you're trying to find the parent function, you are literally just doing the base to the x power. So our parent function here would just be f of x equals 3 to the x power. So that's kind of helpful because now you're just kind of stripping it down and you can compare the function you have to the parent function. The only difference here is that we have a plus 5. So that must mean that the parent function is shifted up 5 units. So let's kind of backtrack here to this picture, right? We said that the asymptote for the parent function is at y equals 0. It's on the x-axis. Well, if I am shifting my function up 5 units, that asymptote is going to move with it, okay? So anytime you have a vertical translation, your horizontal asymptote will move that many units. So I can say that the horizontal asymptote, I'm just going to abbreviate it here as HA, would be at y equals 5. It'll shift up 5 units just like the function did. So let's do it for a second one here. Okay, again, my parent function is the base, which is a fourth, just raised to the x power. Okay, so this is my parent function. So any other number you see is some type of transformation. So the -1 that we have up here by x, okay, remember minus is actually going to be moving right for horizontal translations. So it's going to shift right 1 unit. And then we have a number in front. Okay, so this number is different from our base. Okay, that is the a value, so that controls stretches, compressions, reflections. Okay, it's positive, so it's not a reflection, but since it's greater than 1, that is going to make our graph vertically stretch, if I can spell it right. So the last thing here is, determine the location of the horizontal asymptote. Now, we had a translation, but it was right 1 unit, okay? If I'm moving my graph left or right, that's not going to affect the horizontal asymptote, okay? The horizontal asymptote only raises or lowers, and that's controlled by vertical translations. So the asymptote here is still going to be located at y equals 0, just like the parent function, because there were no vertical translations. All right, so that is it for this video. As far as actually graphing exponential functions goes, you will simply be typing the functions into your calculator, looking at a table of values, and plotting points. So I hope you have a great rest of your day, and let me know if you have any questions.